Hello, we are discussing about GATE 2013 ECE paper, and this question is related to analog circuits. Look at the circuit shown. What is the output voltage V out if a silicon transistor Q and ideal op amp are used? Transistor Q is silicon transistor and op amp is ideal. Then what will be the output V out? Options are minus 15 volts, minus 0.7 volts, plus 0.7 volts, plus 15 volts. So the right answer for this question is B. V out is equal to minus 0.7 volts. We will see how. First of all, look at this one. This op amp, is it inverting amplifier or non-inverting op amp? Whether it is inverting op amp or non-inverting op amp. So for that one you must check where you are going to be applying the input signal. Input signal is 5 volts through 1 kilo ohm resistor that is applied to the inverting terminal of the op amp. So that this is going to be called as inverting operational amplifier. Inverting operational amplifier will provide 180 degrees phase shift, so output will be 180 degrees out of phase with input signal. So since V input is going to be positive, you are applying positive voltage plus 5 volts, so V out will be of negative nature. So whenever V out is negative, at that time this is NPN transistor. Here it is, as the arrow goes, this because of this arrow direction we can say that when it is NPN transistor. So for this NPN transistor, P is connected to 0 volts and N side is connected to the negative voltage. That implies nothing but this PN junction will be forward bias. Okay, and whenever the PN junction is going to be forward bias, that is emitter base junction of the transistor is forward bias, there is a chance that one Q maybe comes into the on condition. Okay, and look at this one, it has given as ideal op amp. Ideal op amp implies nothing but which will be having the virtual short. Because of virtual short, you will get the same voltage across the inverting terminal also, which is present at the non-inverting terminal. This is mainly because of AV property. Voltage gain of op amp is going to be treated as infinite. Voltage gain is nothing but output voltage by input difference voltage. So by that time you can say it as VID is equal to V0 by AV, which is infinite, so that it is 0. VID you can write it as V plus minus V minus is equal to 0. That is, the difference between non-inverting and inverting terminals is always 0, which implies nothing but V plus is always equal to V minus when AV is infinite. Whenever open loop gain is infinite, by that time there is a situation called virtual short. Because of that virtual short, V plus is equal to always V minus. Okay, so because of that one we can say that one over this point you are getting 0. So the current flowing through this 1 kilo ohm is nothing but 5 divided by 1 kilo ohm, so it is 5 milliamperes. The 5 milliamperes of current it is flowing through this 1 kilo ohm resistor, but it cannot go through this one because Ri is equal to infinite. Input impedance is going to be, input impedance of op amp is infinite. Because of that one no biasing currents are flown. That implies nothing but no currents are flowing into the input terminals of op amp. That is, no current flows through non-inverting terminal as well as inverting terminal. Current flowing through the terminals of the op amp is 0. So if this 5 milliamperes is not going through this one, it has to go through in this way because it has to satisfy the KCL. So that implies nothing but this is 5 milliamperes. So 5 milliamperes is flowing in this way and it is passing through this collector. Now the transistor Q is in the on condition. Whenever the transistor Q is in the on condition, we can say V out. Okay, from this one, V out implies nothing but voltage from output terminal to ground terminal. Output terminal to ground terminal is nothing but this is output terminal. V out is nothing but output terminal. Output terminal is nothing but emitter terminal of Q. So VEQ minus, okay, base terminal of transistor, that is nothing but VBQ, which is connected at ground. Output voltage is nothing but voltage from output node to ground. Output node is connected to emitter of transistor and ground node is connected to the base of transistor. So that what we are writing is V out is equal to VEQ minus VB. Okay, that implies nothing but you can write it as VEB. So you can write it as minus of VBE, and VBE is going to be base to emitter voltage, which is forward bias, so that the voltage across base to emitter junction for silicon transistor is 0.7. VBE is 0.7 volts, so that we can say that when it is V out is equal to minus 0.7 volts. This is the answer. So the right option for this question is B. Thank you.